In the second item on the first test, we have a steel plate that's embedded in a concrete block. That block is being pulled at 2,500 pounds, 2.5 kips. And so note that we've got that embedment depth of 8 inches total. Right? And we're asked to find what the average shear stress is between the steel plate and the concrete. We're going to ignore the normal stresses that happen at the bottom edge of the plate. So when we go look at this equilibrium diagram, what we've got going on are all of these little shear stresses. This is on that broad face of the plate, right? As though we're trying to pull this out, sort of like a skin friction kind of thing. You have it on all 4 surface areas, all of those. And actually there would be normal stresses down here at the bottom as well, but we're going to neglect those, and we're only going to have these here, these shear stresses that we're going to assume are constant everywhere over that whole shear area. So since all we're asked to do is find the average shear stress, this is a pretty straightforward direct calculation. We first need to get this shear area. And we got a rectangular plate, 4 edges, 2 of which are identical on either side. So our shear area then will be equal to 2 times those rectangles, so 8 times 1.5 inches, that's this broad face, plus 8 times the thickness of the plate, which is 5/16 to get that edge, and add that all up and you get 29 square inches. So that means that our shear stress equaling our shear force divided by the area in shear, and by equilibrium that shear force has to equal, in this case, 2,500 pounds divided by 29 square inches, and we get then 86.2 pounds per square inch.